Google has opened API access to their Gemini Pro model, and you can use it for testing for absolutely free. Gemini provides a number of integrations with different large language model platforms, which include LangChain, Llama Index, and many others, which you can see over here as well. In this tutorial, we will learn how we can chat with multiple documents using the power of LangChain and Gemini Pro model. So let's get started with it. So let's first look at the architecture over here. Let me zoom in. So the user will first upload all the documents, which can be in the form of PDF files or docs files or in the form of PowerPoint slides. So the user will upload all the documents. So in this tutorial, I will be uploading different PDF files over here. So after the user uploads the documents, which can be then the form PDF file, Word files, or in any other format, we will extract the data from those PDF files. So in the first step, the user uploads the PDF file, and then we extract all the data from those PDF files. So now in the next step, we need to split the data into different chunks. So why we need to split the data into different chunks is that Gemini Pro model has an input token limit of 32,000 tokens. Like you can say that Gemini Pro model has an input context limit of 32,000 tokens, and 1,000 tokens are equal to 750 words. So when you upload multiple PDF files, so if you see as Gemini Pro model has an input context limit of 32,000 tokens, and as I told you, 1,000 tokens are equal to 750 words. So if we see 32,000 tokens will be equal to 24,000 words. So if you just do the calculation, 32,000 tokens will be equal to 24,000 words, as 1,000 token is equal to 750 words. So now when we upload multiple PDF files, so there is definitely a case that when we extract data from those PDF files or any other documents, so their data can be more than 24,000 words, because we can pass maximum 24,000 words as an input to the Gemini Pro model. And we can have, when we extract data from the documents which we have uploaded, we can have more than 24,000 words in those documents. So we cannot pass that data directly to the Gemini Pro model, because Gemini Pro model has an input limit, like it can handle maximum 24,000 words at once. So what we do is we then split the data that we have extracted into multiple small chunks. So we will define that we will define the character limit, like how many characters do we want to have in each of the chunk. So based on the character limit which we define, we will split our data into different number of chunks. So based on the character limit, we can have 10 different chunks or 20 different chunks. Then in the next step, we will create embeddings for each of the text chunk. So first we will extract the data from all the documents. Then we will split the data into very different small chunks based on the character limit which we have defined. Like these are the maximum number of characters that we will have in each of the chunk. Then we will create embeddings for each of the text chunk. So embeddings are basically used to compress the size of the data. Embeddings are basically vectors which contain basically floating point numbers. So we have converted our data which is in the form of text into embeddings. So now our data is in the form of floating point numbers. Like you can see that 0.1, 0.3, 0.3. So now in this way, we'll create embeddings for each of the text chunk. Then using those embeddings, we will using all the embeddings which we have created for each of the text chunk, we will create a we will build a semantic index. Like you can see over here, we will build a semantic index. In the semantic index, we will have all the embeddings, like you can see over here. In the semantic index, we will have all the embeddings, and then we will save all those embeddings in a knowledge base or a vector store or a vector database. So there are different vector database available, like Chroma DB files, which are basically offline databases, and you can using Chroma DB or files as vector database, you can save the embeddings locally. But if you want to save the embeddings in the cloud, you can use Pinecone vector database. But in this tutorial, I will be using Chroma DB as our vector database. So now we have converted our all text data in the form of embeddings. Like we have converted text data into chunks, and then we have converted chunks into embeddings, and then we have saved all the data in the form of embeddings in our vector database, which we are using as Chroma DB. Next, what we will do is, now we have saved all the data. So if the user asks any question, like if the user asks a question that exists in our documents which we have uploaded, so first, if the when the user asks a question, we will create embeddings for that question. Then we'll do a semantic search. We will try to find out the answer. So now you can see that the user has asked a question. We have created embeddings. So now our question is in the form of embeddings, which are in the form of floating point numbers. So now we will do a semantic search. We will try to find the embeddings that are closed, or like you will say that we will try to find top 4 answers for this the question that user has asked. So which the answer will be definitely in the form of embeddings as well. Then we will rank those answers, like we will just rank those answers that we get from the knowledge base based on the question that the user has asked. Then what we will do is we will just pass the question that the user has asked directly to the large language model, and then we will also pass the response that we got from the vector database to the large language model as well. And large language model will then generate a natural response for the question that the user has asked. So this is how the complete architecture looks like. So I have already created a Google Colab notebook for this. Over here, you can see the Google Colab notebook. So let me just reconnect it up from here. So in the first step, we will install all the required packages, which you can see over here. So let me just install all these required packages. As I told you that we will be using LangChain to implement. We will be using Gemini Pro Model within the LangChain framework. So I will just install LangChain-Google-generated AI. Then we have Python-dot environment. Basically, we require this package so that we can load our API key. So let's get started by installing the packages. So over here, I will be using Gemini Pro Model within the LangChain framework. So let's install all the required libraries from here. So from Google.generative AI, we are importing generative AI, and from Google.colab, import user data, so that we can securely secure our API key over here, like you can see. Okay, so then we have from dot environment import load dash dot environment, so that dot environment package, so that we can load the API key. And to display any input image in the Google Colab notebook, or to display any output image in the Google Colab notebook, we import display library. Then we have markdown, so that we can just format the text into a very nice format using markdown package. And then we have the test wrap library. Okay, so let's import all the libraries. Then we'll set up our API key. So if you haven't got your Gemini Pro Model API key, you can just click over the link over here, and you can just redirect to the site which is provided over here. So you can just go to Google AI Studio, and our Gemini Pro Model API key is available under Maker Suite. So you can simply click on create a new API key in new project, and you will be able to create the API key. You can see that I have created different API keys which I'm using in my different projects. Okay, so now you can see over here, like you can see user data.get Gemini Pro key. So if I just go over here over here, so now you can see over here in the secret tab, I have just created, you can see that I have just passed my API key over here. So if I just opened it, so you can see the API key over here. So what I have done is, if I just go over here again, if you just click over here and generate a new API key over here, so this might take few seconds before it generates my API key. So you can simply copy this from here. Okay, and what you can do from here is you can click on add new secret key, and you can just so now whatever name you write over here, please remember that name. So this will be the name of your environment variable. So we can simply write the same name over here. So you can just copy this and just write the same name over here, and you can just copy this API key from here, and you can just add that API key over here, and you can just hide this API key. Okay, and you can just simply make it able to access from the notebook. So in this way you can see how it works. Okay, so if you want to add some other secret key, you can add new secret key as well, and you can delete it as well. So I've already added two secret keys over here, and please remember that name. So this will be the name of your environment variable. So okay, so now we will just run this over here. So we are just setting our API key, and now we'll just create a new environment .environment file in the workspace over here, and we will store the API key in it. So now you can see over here what we have the API key. So I will just copy this from here. So now I will just run this cell from here. So now you can see .environment file has been created in the workspace, and we have stored our API key in it. So let's see if we are able to load the API key. So that's work fine. So now over here, now we are just creating a function to dash markdown. So this will, when we get a response from the Gemini Pro model, so we will just convert that response into a nicely formatted text. So that's why I've created this function. So now I will just generate a list of models that are available under that are available provided by the Gemini Pro model. So I will just publish or print the list of different Gemini Pro models which are available. So now you can see we have the Gemini Pro and Gemini Pro Vision. So if we want to input text and generate a text response, then we can use Gemini Pro model. And if we want to have an input in the form of text or image, then we can use Gemini Pro Vision model. So if you have input in the form of text and image, then you should use Gemini Pro Vision model. Okay, so here from generative AI, I'm using the generative model function, and here I'm just using the Gemini Pro model, which you can see over here, because currently I'm just passing my input, which is in the form of text, not in the image. So I've just passed the input, what is the meaning of life, and here it will just calculate the time it takes to generate the response. And to print the response, we will just write response.text key. So this will generate the response. So over here, if I just run this, so now here we have the to dash markdown. So that's like you can see that this is the response generated by the Gemini Pro model. But to make this response into a nicely, to make this response look in a nice format, we can just use response.text. So now you can see that this response is now in a very well format. The meaning of life is multifaceted question that has been pondered by philosophers and individuals throughout history. The search for meaning in life is deeply pursued, influenced by various aspects of human experience, belief, values, and goals. While there is no single universally accepted answer, here are some common themes and perspectives on meaning of life. So you can see all those perspectives and meanings of life over here. So it looks a good response. So currently you can see that we have not used a LangChain framework to generate a response, text response based on the question that we have asked over here. So now we will just use LangChain to assess Gemini Pro model. So previously we are just generating the text response directly using the Gemini Pro model. So now we will use LangChain to assess the Gemini Pro model. So first we will do is what will generate text from the text input. So over here you can see from LangChain Google Generative AI, I am just importing chat Google Generative AI. So the package. So now you can see over here, let's run this cell. Then over here you can see that I'm just initializing my Gemini Pro model over here and using LLM.invoke. I'm just passing the question, what is mean average precision? So basically mean average precision is a metric that is used to evaluate any object detection model. So mean average precision is a metric that we usually use when we try to evaluate any object detection model like YOLO V8, YOLO NAS, YOLO V7. So now we are just using LangChain framework to assess the Gemini Pro model. So now you can see over here, we have the response mean average precision is a widely used evaluation matrix in object detection and image classification task. It measures the average precision of model prediction across all classes. So it's a good response. So now previously we used LangChain to assess Gemini Pro model. Now we will use LangChain to assess Gemini Pro vision model. So in Gemini Pro visual model, we generate text from image and text input. So in Gemini Pro vision model, we do two things. We provide input in the form of text and images. So in Gemini Pro, we only provide text as input, but when we are using Gemini Pro vision model, our input is in the form of text and image as well. So basically, Gemini Pro vision model is a multi-modal model provided by Gemini that can handle input both in the form of text and images. Okay, so I have just written this function over here so that I can just display the input image. So the input to this function will be the URL of the image. So over here, you can see that this is the URL of this image, and I have just passed the URL of the image over here. And we are just using the display library, which we have imported at the start. I am just displaying the input image into the Google Colab notebook over here. Okay, so this is the input image. So now we will be passing this image as an input to our Gemini Pro vision model. So if like you can see over here from langchain.dashcode.messages, I am importing human message, and from langchain-google-generative AI, I am just importing chat Google generative AI. And over here, you can see I'm just passing Gemini Pro vision model over here. And like you can see there, we have a different type of structure of input over here. Like you can see, we have two different dictionaries over here. And first we are passing the type of the input is that in the form of text, and our text is what is in this image, and we are just passing this image a URL over here as an input. So let's see what LLM gives response. So if we just see over here, let's wait for the LLM to generate the response. A snow-capped mountain at sunset. So now you can see when the sunset is appearing, the sunset is going on, and you can see a snow-capped mountain over here. So you can see a snow-capped mountain at sunset. So it has predictably given the response over here. So now I have just I have another image over here. Like you can see over here, there are different vegetables over here and rice, and we can see different vegetables over here in this image. So let's pass this image as an input to my Gemini Pro vision model. So I will just like write type text. So write a detailed blog post based on this picture, which I'm just showing you over here. Make sure to cover each and every aspect in the blog post, and I'm just passing this image URL as an input to my Gemini Pro vision model. And let's pass this to my Gemini Pro vision model, and let's see what response do we get over here. So this might take few seconds. Okay. So now you can see over here, we have the response over here. Okay. So you can see that there are different vegetables and brown rice I can see in this image. So it has generated a response over here. So I have just passed the input text as write a detailed blog post based on this picture. Make sure to cover each and every aspect in the blog post. So the response is, are you looking for a healthy and delicious meal preparation idea? Look no further. So it has given me like you can generate this type of meal using uh, the ingredients which you have currently. So and it has to make this meal, you will need the following ingredients, and it has provided the ingredients as well, and it has provided the instructions like how I can prepare this meal. So that looks good. So now we have seen that how we can use LangChain framework to use Gemini Pro and Gemini Pro Vision model. So we have used LangChain framework to assess the Gemini Pro and Gemini Pro Vision model, and we can see that we are just getting very good results as well. So now we will learn how we can chat with documents using LangChain and Gemini Pro model. So we will learn how we can chat with different documents using LangChain and Gemini Pro model. So over here, first I will install all the required packages. So I require LangChain. as we are using LangChain framework create and to chat with our documents. And then we have PyPDF so that I can load the PDF file and extract the data from those PDF files. So then we have Chroma DB because we are using Chroma DB as our vector database. So now from here, we are just in for LangChain, we are importing prompt template. So we'll just pass an input prompt. Okay, so in large language model, we do not pass the question, our question directly to the large language model. We pass our question to the prompt and in our prompt template, and then we pass the prompt template to the large language model. So let's restart the session. Okay, and let's import all these required libraries. Then we have load query chain so that we can establish a question answer chain and we can chat with the documents. And then we have PyPDF directory loader so that we can upload all the PDF files that we have in our directory. Then we have recursive character text splitter so that I can split my text into small chunks. So over here you can see we need to split our extracted data into small chunks. So we will use PyPDF reader recursive character text splitter so that we can split our data into small chunks. Then we have Chroma, which is our vector database. Okay, so let's import all these required library. So now I will be just creating a folder over here by the name PDFs, and inside this folder I will just add all the PDF files. So I'm directly downloading the PDF file from my Google Drive into this Google Colab notebook, and the PDF files will be added in the PDF folder which we have created over here. So like you can see over here, we have both of the PDF files over here. So now using PyPDF directly loader, I will just load the PDF files and extract the data from those PDF files. So using load and split, we will split the PDF files into different pages, or we will split the extracted data, the data which we have extracted from those PDF files into different pages. So like you can see that on the page number 3, like it starts with 0, 1, 2. So on the page number 3, we have this data you can see over here. And this is all the data which we have extracted from the PDF file. So this is a huge amount of data. So now let's see the number of words which we have in our data which we extracted from the PDF files. So now you can see we have 76,045. Like we have seen that the input token limit of Gemini Pro model is 32,000 tokens, and if we just see 1,000 token is equal to 750 words, so it can handle, Gemini Pro model can handle 24,000 words at the input, but you can see we have 76,045 words. So what we will do, we will split all the extracted data into small chunks, and then we will create embeddings for each of the text chunks. So now using recursive character text splitter, we are just splitting our data into small chunks, and the chunk limit is 10,000 English characters. So each chunk has an input limit, like there are the number of characters that can be stored in each of the text chunks which will create will have maximum 10,000 English characters, and there will be an overlap of 200 English characters among each of the text chunks. So now you can see we have created 9 different text chunks. So you can see we have created 9 different text chunks. So we have splitted our extracted data into 9 different text chunks. You can see over here, and this is the data which I have in the text chunk number 1. Okay. So now I will just download the embeddings from Google. So Google also provide an embedding model as well. So I will just download the embeddings from the Google. Okay. So now you can see here we are just passing, please add an environment variable Google API key. So let me do this. So when we restarted the runtime, we should have done this process. So I'm just missing this. I just need to rerun this cells again because I have restarted the runtime. So let's go below down. Hopefully it will now work fine if I just go down and run these cells up again. So let's run this. So now I will just download the embedding model from Google. So I've done this. So now we'll create embeddings for each of the text chunks. So now what we are doing is that we are creating embeddings for each of the text chunk, and then we will store those embeddings in a vector database, which is Chroma DB. So now we are doing create embeddings for each of the text chunk and save them into a vector store. So that we are doing over here. So now over here, like you can see, I'm just asking a question. So when a user asks a question, we will create embeddings for that question, and we'll try to find the answers from our vector database, and then we will basically the we will try to find the similar embeddings from the vector database, and then we will convert the embeddings back to the in the words format, and then we will rank those results. So I will just ask a question: Rachel Green honors and awards. So if I just download this PDF and show you how this PDF looks like. So if you just see over here, this is the PDF. So this is the resume of our girl, Rachel Green. So here you can see in his resume, he has mentioned the honors and awards that she has got. So see, this is a dummy resume basically. So I'm just asking the honors and awards that Rachel Green has got. So like, let's see. So now you can see that there is a lot of responses that are generated over here. Okay, so like you can see over here, basically we get a lot of response from here, and then we will just pass these responses to the our Gemini Pro model, and we will pass the question directly to the Gemini Pro model, and Gemini Pro model will generate a natural response. So so here is the prompt template, and I'm just passing the prompt template. Answer the question as detailed as possible from the provided context. Make sure to provide all the details. If the answer is not provided in the context, just say answer not available and don't provide the answer. So if we don't have the answer available in the PDF file, I'm asking my Gemini Pro model to don't give me the wrong answer. Just say answer is not available in the PDF files. So this is the data, and we have just passed the context, like I'm just passing this documentation as context, and the question which I have asked as Rachel Green as honors and what. So both of these things, docs and question, are passed and is an input to the Gemini Pro model, and we are using Gemini Pro model over here. Okay, so let's see. So our, like you can see that over here we have the docs and we have the question as an input to the Gemini Pro model, and let's see what response do we get from here. Now you can see that here are we have been provided all the details of the honors and awards that Rachel Green has got. So you can see that Jacob K. Javits Fellowship, U.S. Department of Education, Graduate College Dissertation Completion Award, and then Campus Teaching Award based on student evaluations provided by University of Illinois. So if we just see her resume, so this is a dummy resume which we have created. So you can see that he has got a fellowship from U.S. Department of Education and Graduate College Dissertation Award, Campus Teaching Award based on student evaluation. So we have got the same response we have got the same answer based on the context that is provided over here. So that is good. Let's ask some question from this PDF. So uh, this is basically the research paper on the YOLO V7 object detection model. Okay, so if you just see over here, so this is the paper of the object detection model YOLO V7. So let's ask some question from here. So if I just start right over here, YOLO V7 is used for, let's ask this question and let's see what answer do we get from here. So basically YOLO V7 is an object detection model. So let's see if it gives a correct response for this or not. Okay, so answer is not available in the constant, and that is surprising. So let's ask some other question. YOLO V7 outperforms which model? So let's ask this question from here. So here is our response. YOLO V7 outperforms YOLO V4, YOLO CSP, YOLO V5, YOLO V5S, YOLO V5 medium, YOLO V5 large model. So that is the correct response we have got. And YOLO V7, let's ask some other question. Uh, YOLO V7 is trained on which data set? Okay, so let's ask this question from here. And let's see if we get the correct response or not. So here the context doesn't mention anything about the dataset YOLO V7 is trained on. So definitely doesn't find the answer for this question. Let's, if we just ask some other question, uh, YOLO V7 is used for object detection or not. So let's see what response do we get from here for this question. So here we have the response. Yes, YOLO V7 is used for object detection. So in this tutorial, we have seen that how we can assess a Gemini Pro model with LangChain. And we have also seen how we can assess Gemini Pro model, Gemini Pro vision model with LangChain. And we have seen that how we can chat with multiple PDF or multiple documents using the power of LangChain, Chroma DB, and Gemini Pro model. So that's all from this tutorial. Thank you for watching.